Hello everyone, I'm Michael Lee, Solutions Engineer at DGI, and in this video we're going to explore post-processing in FlightHub 2. First, we'll review cloud reconstruction, which enables users to generate high-quality 2D maps and 3D models directly from FlightHub 2. All models will be stored in the model library right here in FlightHub 2. Note that you can also import any models if necessary, which will be right here in the import button. You can see we can import 2D, point cloud, and mesh and have several different models. So if you want to, you have the ability to select right here and import model. So now that we're in the model library, I'm going to walk you through how to do a cloud reconstruction. We're going to start by clicking Start Mapping. We're going to name our model. And we're going to select photos. From here, you have the option to select photos by flight route or folder. So you can see our photos that we were taking over this building. Next, we have the option to have 2D or 3D model. We're going to select 3D modeling. We're going to select 3D mapping. And then the mapping scene, we have two options. We have normal, which you can select if your drone has collected photos from a standard grid flight pattern covering a rectangular area from above, or you have circle, which if you gathered your photos using a flight route that was circled around an area of interest, such as a perimeter, building, or a specific object, you would select circle. Next, we have resolution speed. So lower the resolution is going to provide you a quicker model, and higher resolution is going to take longer. It's going to be slower to process. So you can choose depending on your mission needs or how quickly you need that model. Next, we have region of interest. When enabled, the reconstruction output will be limited to the defined region of interest. Going below, we have a few model outputs that we have options to. So if we select mesh model, we have a few formats. So this will be created to create your basic 3D model used for detailed visuals. You have point cloud model that can provide a point-based representation used for data analysts. And then you can also use rough model for smart 3D capture. This provides a basic model for your initial capture. Next, we have our coordinate system. In FlightHub 2, the coordinate system sets where your 3D map fits in the real world. You can pick a known coordinate system like WGS84 for global georeferencing, or use an arbitrary coordinate system for relative positioning. You can search or you can expand. So I'm going to show you right here. You're able to search or expand these lists for any specific systems, ensuring that your mapping data aligns accurately. And then last, we have our model specification value. A smaller value indicates more simplification and less in detail. So this is good for browsing the model in the cloud, or you can also change to a larger value if greater detail is required. So once that's complete, we would select OK. And you would actually start to see your model processing right here. So you can see pending and now switched to 1%. I've already processed this model previously, so I will open up this model right here. So from here, you can view your 3D reconstruction directly. You can also overlay it on a map. So if I were to click overlay on map, I can exit out of this and go to map models. And now you can see the model we just generated on the map. So some other cool features we have is a compare feature. So I'm going to go ahead and go to another project and show you a model. So FlightHub 2 offers manual compare tools to support efficient model analysts. So you can manually compare models and visually inspect 2D models or reconstruction side by side. So in this particular model, we're going to select the compared icon right here. Then this uses a transparency slider and timestamp overlaps so you can manually spot differences over time. This approach gives us a full control of what is viewed and how these changes can be seen. So now I'm going to go over change detection. So right here you can see detect changes. Another way we can compare models is through the model change detection feature, using AI to identify and highlight changes between overlapping 2D models. So this is going to help users monitor site progression or detect any anomalies over time. So to reminder, we are in the model library. And what we would do is select detect changes and start a new task. Any old tasks would be here. We would select a new task. And then now we can name the task accordingly. We can select the objects that we want, so the model that we want. And then from here, we can define an analyst scope, either all, or you could draw region of interest. You can apply filters if needed, such as ignoring vehicles. And you can also set a minimum change size to refine detection. So once all that has been selected, we can select Start Detection. And after running the analysis, the AI marked change regions are going to be displayed and can be reviewed, edited, or annotated. So currently right now it's loading the algorithm. So once all this is done, you're able to view a detailed report with any change statistics, images, and coordinates can be generated and exported. All the AI detection records are all stored here for easy management and review. Thank you so much for watching.